Okay, whether the screen is visible?
Yes, sir.
Yes, sir.
Yes.
So
Very
actually,
good.
to other assignments, this one is a little bit good. Okay. So, but the problem is again, here also there are some mistakes. For instance, let me show. This one belongs to this group or the other one?
So other one, sir.
Other one, okay. So again, see, this one is good, but only thing is like this. Sorry. So this 10 amount, the vehicle, right, that should not come inside. So that is the problem. And after that, so apart from that, the arrowheads, the dimension, everything looks comparatively good compared to others. So that's what I'm trying to say. Even if you look at this, the title block. So the title block of this particular assignment is good. Okay. So that is for the assignment one. Now in assignment two, many have not done properly. So I evaluated all the assignments. What is the reason for that? Is there any issue with the understanding? You're able to understand it, right? Someone can answer. A few times about this. So still many are doing writing the amount here. That is not the right practice. Still you are not able to follow that. Okay. So that was my concern. So still there are few mistakes, something like this. Okay. So that's what I wanted to address. Okay. So listen carefully. If you have any doubts, you can ask me then and there, and try to improve the drawing. I can understand that. So you are not present physically, and you are not seeing eye to eye. So you are seeing through some medium. I can understand, like, it's not that easy, but still try to improve that. Okay. So that's what I want to emphasize. Okay. Is there any doubts with respect to the assignment 3?
Yes, sir.
So what you need to do is you need to do for off distance. That means pi d by 2. So that is the distance. So what we need to do is you need to draw the lines. You need to divide the small circle into 8 parts, something like this. Small circle into 8 parts, and you need to draw horizontal lines from the for these divisions. So let me write this. So it is going to rotate in the clockwise direction. So this will be my 1, 2, 3, 4, 5, 6, 7, and 8. So it needs to rotate to the off revolution. So that means the 8.8 will come upward. Okay. So next, we need to make horizontal lines from these points for the distance of pi d. So I can ask something like this.
So, sir, we
Okay.
have to draw from the distance of the generating circle.
Yeah, distance of the generating circle. That's what I try to explain. Because the movement of P is defined by the generating circle, not the imaginary circle.
Okay, sir.
See, the P should come to the starting point. What is the distance it takes? The pi d. D is for
Pi.
generating circle.
Yes, sir.
Because they are like constrained. The movement of P is restricted to the movement of the generating circle.
Yes, sir.
Yeah. So this is how you need to do. Is it clear?
Yes,
Yes,
sir.
sir.
Yes. Okay, let me ask you one thing. See, today I'm trying a different method to show the drawing. Is it okay, or are you able to visualize this?
Yes, sir.
Yeah. Okay. So now let's move to the today's topic. Today I'm going to cover the involutes. Okay. So it's a next type of curve. So I will show you how the involutes are generated. So before that, like, let me discuss the basic things. Okay. See, for example, you have a you have a circle. Okay, a drum. Okay, and in one end of the drum, yeah, a string is how to say tied. Okay, and the length of the string is exactly to the circumference of the drum. Okay, so when you try to unwound the string and by applying the tension, so what will happen, it will get unwound, right? So at that time, if you trace the end of the string, you will get one particular curve. So that curve is called involutes. Okay, last week I didn't get time to make a video for this, so that's why I didn't make video in YouTube for this particular topic. Okay, maybe if time permits in the coming days I will do it, and there I will try to explain how the involute is generated. Okay, so because last week I was a little busy, so I'm not able to make a video for this. Okay, so that's how the involute is generated. The involutes can be generated uh, from a line, from a circle, from any polygons like triangle, square, rectangle, hexagon, etc., etc. Okay. So in today's class, we are going to see two involute. One is the involute of a square, and second one is involute of a circle. Okay. So that's what I'm going to do today. So first, and it has wide range of applications. We already discussed this particular mechanical component that's called gear. Gear is one of the important mechanical component. So that, what is the purpose of gear? Any idea? What is the purpose of using
Connect
gear?
the motor with the
Sir, to
AC
increase the decrease torque.
Sorry, come again. Your voice is not audible. Can you say it again?
to connect the motor
Sir,
with
to
the wheel
increase the
of any vehicle.
Okay. I'm in the toys. Have you seen this? Just a moment. I'll show you here.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, so
Yes,
this
sir.
individual component is called gear, and in the two-wheeler or four-wheeler, we used to call that as a gearbox. In the gearbox, there will be multiple of this type of gears. Okay,
Yes, sir.
yeah, this is one of the important mechanical component. Take any day-to-day application or anything, you will see at least one of these gears, even in the toys. Okay, so the
Gear.
purpose of, yeah, the purpose of this gearbox is to transfer the rotary motion. Okay, so from one axis to the other axis, it can transfer the rotary motion. See, for example, if there are two gears like this, and I think this is visible. So, for example, if you're connecting motor here, and if you're connecting one more shaft here, so from the motor, the rotary motion will be transferred to any other place. Okay, so that's why this gear is used. In these gears, look at this. These are called teeths on the circumference. The profile of the teeth, that is of involute profile. Okay, so that is one of the important application of involute, because it has certain advantages. It has some, it can maintain the pressure angle, so the friction will be always That means the contact point will be always a line, not a surface, so that the energy loss or the heat generator will be minimized. So okay, these are the few applications. Okay, so this is the basic introduction about gears. Okay, and the application of involute, which is gear. Okay, now let's go to the construction of involute. Let's start with the square because that is little easier. Let's start with the square. Okay, so let me read the question first, or let me write the question. I'll write it here. Okay, so this is the question. So they mentioned that you need to draw the involute of a square of 25 mm and draw tangent round. Okay, so first what we need to do is, so again you need to decide so whether the unwounding happens in the clockwise direction or anti-clockwise direction. Okay, so let's make a square something like this. Okay, just made a square like this. Okay, so whether my screen is visible, if not, like please let me know.
No, sir. Sir.
Okay, so the next thing is you need to name the square. Okay, so what I'm going to do is I'm going to unmount in anti-clockwise direction. So something like this, in the clockwise direction. Okay, I'm going to do it in the clockwise direction. So what I'm going to do is I need to decide the fixed end. See, for instance, I'm going to assume this is my fixed end. Okay, so you need to name it properly, something like this, alphabet using alphabet A, B, C, and okay. So something like this, you need to name this. Okay. So the next step is you need to calculate the perimeter of the square. So the perimeter is something like 4 into side. One side is 25 mm, so 4 into side is 100 mm. So for the length of the perimeter, you need to make a line from here, this point. You need to make a line for that length, and this length is nothing but the length of the perimeter of the square. Okay. So then after that, from all the points, you need to extend the line. Okay, from all the points. So from point A, similar to D, I need to extend it from point A. Point A, point B, point C. Okay. So like that, you need to extend from all the points. Okay. And the length of this line. So length of let's take this as D. D dash. The length of D dash is the length of the perimeter of the circle. So that is nothing but 100 mm. Okay. So after doing this, what you need to do is you need to take A as the center, and I'll mark it. A as center. Distance between A to D as radius. Okay. A is the center, and the distance between A to D as the radius. You need to make a knot, something like this. Okay. Are you able to follow?
Yes, sir.
Yes, sir.
Okay. Next, you need to draw till this line. So next, what you need to do is, so let me name this as P1. Okay. The next step, what you need to do is, you need to take B as center and B to P1 as radius. So can someone can see like what is the what will be the distance between B to P1? Because B to A is 50 and B to P1 is 50. So that means like 2 into side. So that is the radius. You need to make an arc till that line, something like that. Okay. Next, C as the center, C2, P2 as the radius. You need to make an arc like this. Okay. And finally, this is P3. And finally, you need to do it till like this. So you will get something like this. Okay. So this is how the involutes needs to be joined, needs to be constructed. Okay. So let me ask you a question. So can someone suggest like, see, I want to, they say like draw tangent and normal at any point. Let's assume that I have chosen this particular point. Okay. Can someone suggest how to draw normal? Any idea?
Taking B as a center.
Yeah, because this is just a quarter circle. So for the quarter circle, the normal is nothing but from the center you need to draw a line to that point. So that will be your normal. So if I want to do in this point, from C you need to draw a line. From here for this point you need to draw. From B you need to draw a line. For this from A you need to draw. So that's how you need to draw. Okay, let me draw that. So this will be your normal. The line perpendicular to that. Oh my God. Okay, you draw the normal. The line perpendicular to that, that will be your tangent, something like that it will come. Okay, and you need to name this as, sorry, N dash, and T dash. Is that clear? So you copy this, so I'll give some 2-3 minutes. So after that, we'll go to the next topic. The hash pencil. So the remaining lines are should be drawn to each pencil. So I can say like this is one of the easiest curve you will get. See, so the other curves are like comparatively it's complex. The construction part is very complex than this, but this is the easiest curve you will get. Okay. So can I go to the next slide? Next topic.
Remaining with 2H pencil.
Yeah, remaining to each pencil. Yeah. First, you need to draw the circle for the given diameter, that is 30 mm. Okay. So I drawn the circle something like this. So then, as we always do, so we need to divide the circle into some divisions, convenient divisions. Let's take 8. So can someone say like what is the reason for dividing a circle into some divisions? I didn't do it for the square, but I'm always saying like we need to divide the circle into some convenient division. What is the reason for that?
It has no corners, whereas square has corner.
Yeah, it does not have any defined corners, whereas the polygons have corners. So you no need to do that. Okay, that's a good answer. So divide the circle into divisions. Okay, so I divided this again. So whether you want to unbound in the clockwise direction or anti-clockwise direction. So it depends upon that you need to name it. If I want to do it in the clockwise direction, then numbering should also be done in the clockwise direction. So I'm going to name this from here. It should be 1, 2, 3, 4, 5, 6, 7, and this will be my 8. Okay. So the starting point is 8. So I am going to assume that at point 8 the string is rounded. Sorry, string is tight. Okay. So from there I need to make a horizontal line. So what should be the length of the line? So because if I completely unbound the string, what will be the length of the string?
Circumference.
Sorry, your voice is not audible.
Sir, circumference.
So 2 pi r.
Yeah, okay, that should be the pi mean, okay? The length should be pi mean. So something like this, the length should be pi, okay? So you did nothing like at point A you drawn a tangent, okay? So that's what you did. At point A you draw a tangent for the distance of pi d, okay? So you divided the circle into 8 divisions. Then this length of the line also should be divided into 8 divisions, okay? So I'm going to do it. So this also to be divided into 8 divisions. 1, 2, 3, 4, 5, 6, 7, and 8. So the remaining area is okay. So and I'm going to name that as in dashes. So why I'm going to do this is, see, I'm going to unbound the string. When I completely unbound the string, so during the winding in the string, one point will be in contact with 1. So that point is nothing but 1 dash. And the point will be contacting 2, that will be 2 dash. So when I unbound, it will become something like this, and 1 dash should be here, 2 dash should be here, 3, 4 dash should be here, 5, 6, 7, and finally the 8 dash should be somewhere here. So this is the next step. So next what you need to do is, similar to a tangent from point 8, we need to draw tangent from all the points. From 1, something like this, from 2, from 3, from 4, from all the points, all the identified points, we need to draw the tangent, something like this. And from point 5, from point 6, from point 7, and from point A. So I made tangents like this from all the points. Okay. Next, what you need to do is you need to measure the distance between 8 and 1 dash. So I write it here. You need to measure the distance between 8 to 1 dash. That should be the radius. Okay, 8 to 1 dash is the radius, and 1 as center. You need to make an arc. Okay, so 8 to 1 dash is the radius, and 1 as the center. You need to make an arc on the line passing through point 1. And similarly, 8 to 2 dash is the radius. You need to make an arc in this particular line. And you need to do something like this for the remaining points. And finally, the point 8 will come here. Okay. So you need to name this point. So this is my P1, P2, P3, P4, P5, P6, P7, and finally the P8 point will be the 8 dash point. That will be P8. Okay. So next you need to smoothly connect this point with HB tensor. Something like this. From point 8 it should go smoothly. Okay, we will get something like this. So this is nothing but the involute of a circle. Is that clear?
Yes, sir.
So copy this. Yeah. Do you have any doubt? So if not, you copy this. Okay, so assume that, so this is the center. Okay, so from the center, let's take this as O dash. So O dash as the center and O dash M as the radius. Right here. O dash as center and O dash to M. As radius, you need to make a half circle, something like this. See, O dash is the center and OM of the radius, you need to make an half circle, something like this. Okay, you need to make an half circle like this. Okay, so this half circle will cut somewhere on your generating circle. Okay, you look at this one. So it cuts somewhere on your generating circle. Okay. So if you look at this, you can find a similarity. That is, your chosen point is between P6 to P7, and the arc cuts between 6 to 7. Okay. So that means like your bisecting is proper. If you would have chosen a point between 5 to 6, then the arc will cut between 5 to 6. If you have chosen between P7 to P8, then the arc would have cut between 0.7 to 8. Okay, that's how it will happen. Okay, so it cuts here. So from there, you need to connect the point M. So something like this. So that will be your tangent, normal, and a line perpendicular to that. So that will be your normal. So we need to name this as P T dash, L dash, Z. Okay. Any doubts in this?
Sir,
Yeah.
sir, for the arc P6 to P7, the center is 6 now.
No.
Sir, but we draw it by taking the centers.
Let me explain. For the point till point P6, the center is 6. Till point at point P7, the center is 7. So in between, the center will vary. So that's why having said you to draw with compass.
Okay, sir.
Because see, P6 to 6, for P6 to 6, at point 6 the center is 6, at point 7 the center is 7. Okay, so the point will be varied. Okay, so we are like almost finding the instantaneous center for that particular point.
Okay, sir.
Okay, so any doubts in this? So we need to mention two things. Even in the previous question, that is involute of a square, I forgot to do that. You just make a note of this. We need to dimension two things. One is the one given in the question. So that is nothing but the diameter of the circle. In the previous question, the side of the square. So I need to dimension that. So choose any point and dimensioning. So diameter 30. The second thing is this length. So that is nothing but the circumference. So you need to dimension this. So you calculate, you show the calculations here. And you mention the dimension here, okay? Okay, so this is how the involute of a circle needs to be done. Okay. So any doubts in this?
Sir,
Yeah.
we should write calculation with 2H pencil.
No, HB pencil. No, I always remember this. Any text inside the drawing sheet should be done with HB pencil, irrespective of its position.
Okay, sir.
Okay.
Sir,
Any
generating
text.
circle should be with 2H pencil.
No, here again I use. So
Sir, in circles.
generating circle should be with HB pencil. The curve should be with HB pencil. Then normal and tangent with HB pencil. And finally, what else is there? And all the text should be with HB pencil. Okay. So the remaining lines and other things should be done with 2H pencil. Is that clear?
Yes, sir. Sir, please repeat the starting steps of normal and tangent.
Okay. Okay, I'll choose a different point. Is that okay?
Okay. Yes, sir.
Because I can't arrange
Yes, sir.
few steps. So what we need to, let me choose a point between P5 and P6. So let's say I have chosen this point P5 to P6. Okay. So let's name this as M. Okay. What you need to do is you need to draw a line from M to the center of the generating circle, something like this. Okay. After that, you need to find the midpoint of OM line. So I hope you know how to do that. So we found the midpoint. Okay. So next what you need to do is from the midpoint, let's take that as O dash. O dash as the center and O dash M as the radius. You need to make a half circle, and you need to remember one thing. You have chosen a point between P5 and P6. So that means the circle will cross between 5 and 6. Something like this you will cross. You cross between 5 and 6. Okay. So that point is nothing but your instantaneous center. From there you need to connect the M. So that will be your normal. And if you draw perpendicular to that, then it will be your tangent. Is that clear?
Yes, sir. Yes, sir. Clear.
Okay.
So that rough arc for bisecting the line also, that arc and
So that you draw with 2H pencil.
no sir, not that. He told us you have to bisect the alignment. So that rough arc
Yeah,
for
yeah,
bisect,
yeah.
you have to show that rough arc also, or similar, or clearly you have to just bisect it.
No, if it is like if it's a whole number, you choose the point directly. Or it's not that you need to clearly bisect. If you could find the center, that's fine for me.
Okay, sir.
Okay. So anything else? Okay. So I'm closing this. So the next topic is like today we will be seeing one more topic because from next class onwards we are going to move to the second module, that is the projections. So for this I recorded a video. So this is like okay, just a moment. So this is a question. Let me read the question. So I'll play from the beginning. So before that, let me discuss what is meant by Archimedean spiral. So it's nothing but a spiral. Have you seen spiral somewhere in your real time, in your real life?
Yes, sir.
Yes, sir. In the class.
Where?
Sir, anything is chakli.
In the
In the
Sir,
It was
body.
binding book.
no, that is not a spiral. Actually, that is helix. The spiral is see in the toys. There might be a spring, right? You might
Sir, in cracker.
Yes, yes, sir.
ग्वाली
It's a
नहीं खाता है.
broad
Sir,
with like
that is snail.
yeah, wounded thing, which is like sometimes it could be a concentric kind of thing, and there is one more kind of so where inside the toy there are
snails,
three
sir.
balls. You need to move that balls to the center. Archimedean spiral. So this is a question. Let me read the question. A point, capital P, moves around and away from the pole, capital O, for one complete revolution and reaches a distance of 60 mm. Draw the curve traced by the point, capital P, and also draw a normal and tangent at a point, capital M, on the curve. Okay, so this is a question. So in that it is mentioned that it reaches a distance of 60 mm. At the max, it's 60 mm away from the pole, capital O. Okay. So what we need to do is we need to draw a circle for the radius of 60 mm. So before that, let me draw the axis. Hey, before this, I want to ask you. So why no one has filled the feedback?
which type of feedback, sir?
So I have sent a link in WhatsApp. So I asked you to fill 2 times, right? But almost 8 or 9 people filled. Remaining have not filled. What is the reason for that? See, let me be clear. So see, I'm conducting it through online mode, and I don't know like how well you receive what I'm saying. So in order to understand that and in order to improve that, I'm taking the feedback. Okay. don't be like, how to say, uh, don't be, how to say, like, feel something like, how to give feedback. Don't feel that. Whatever you feel in your mind, you give that as a feedback, so that in the coming lectures, because this is only the first module, we have to. I'm going to draw a circle for a radius of 60 mm. Next, what we need to do is, so divide the circle into convenient divisions. Okay. And second thing is, we need to name the center. So in the question it is mentioned that capital O. So I am going to name this as capital O. Okay. And I am going to divide the circle into convenient divisions. So let me divide that into 8 divisions. I divided that into 8 divisions. Okay. So next we need to decide whether the spiral goes in the clockwise direction or in the anti-clockwise direction. So if you are assuming the spiral goes in the clockwise direction, the numbering should also be done in the clockwise direction, something like this. So let's assume this is the base. So from here you need to number 1, 2, 3, 4, 5, 6, 7, and this is 0.8. Okay. Next, I divided this into 8 divisions, right? Next, this length of the line, that also we need to be divided into 8 divisions. Okay. The next one, what have you do? What? See, what I'm going to do is, I'm going to divide O8 line into 8 divisions, because I'm going to assume that this is the starting point. From O8, from this line, the spiral starts. So this is the baseline. So I'm going to divide that into 8 divisions. A line into n equal to, and you know, right, this distance is 60 mm. So dividing that into 8 divisions is not easy. Go for dividing a line into n divisions method. Yeah. I divided that into 8 divisions. So next we need to name that thing. So from the center you need to move away, something like this. So the center should be 0, and this will be 1 dash, 2 dash, 3 dash, 4 dash, 5, 6 dash, 7 dash, and 8 dash. So the 8 and 8 dash should collide. So next what we need to do is, we need to make an arc. So O is the center and O to 1 dash is the radius. You need to make an arc till this O1 line. So I'm taking O center, making an arc till O1 dash, something like this. And I'm going to name that point as P1. Okay. Next, similar to that, I'm going to take O to 2 dash as the radius and O is the center. I'm going to make an arc till O2 line. Similarly for O to 3 dash. So I took O to 3 dash as the radius, O as the center, made an arc till O3 line. Similarly, I am going to take O to 4 dash as the radius, and I am going to make an arc till O4 line. Okay. And similarly, so I'm going to do for the other points. So look at this, I have made all the points, all the arcs, okay. So let's name the points, okay. So as I told, I made this as P1 and this should be my P2, P3 and P4, P5, P6 and P7 and this should be my P8, okay. So once we done that, we need to smoothly connect the point from O to P8. Smoothly we need to connect. So due to this, I erase these lines. Let me redo that. So from O to P1, then P2, then P3, P4, P5, P6, P7, and P8. We need to connect smoothly like this. Okay. So this particular row is called Archimedean spiral. Okay. So any doubts till this?
No, sir.
No. Okay. No. So next thing is like the question they mentioned that you need to choose any point and name that point as capital M and on the curve and you need to draw tangent and normal for that. Okay. Let me choose a point. Okay. Let's assume that you have chosen this particular point. Let's assume this is capital M. Okay. So once you're done that, what you need to do is from the point M, you need to draw a line to O, point O. So this is my point M, and from there I am going to connect M, something like this. Okay. So after that, what you need to do is you need to draw a perpendicular line to that particular line. So I'm going to draw a perpendicular line to that. So something like that it will come. Okay. So perpendicular to this line. So this angle should be 90 degrees. So next what we need to do is we need to make one small calculation. We need to find A, which is nothing but a constant. It's nothing but the ratio between small r divided by theta. So the small r is nothing but the distance of OM line. So OM line is there, right? So the distance of the OM line divided by the angle between OP8 line to OM line. So this angle. Okay. I will show with a black line. So from here to from this OP8 line to OM line, the angle between this line. Okay. So see, let's because I'm not able to measure. Let's assume. Okay. So the horizontal line is 180 degree, and this is 270, and this is 220, 225. So it's little greater than 225. Let's take 235 degree. Okay. 235 degree. Okay. So you need to convert that 235 degree into radians. Okay. I hope you know how to convert that into radians. If not, 235 into 5 divided by 180. If you do that, you will get radians. Okay. So we'll get some value. So you will get as the OM distance divided by that angle in radians. Okay. So if you take the ratio of this, you will get some value. So that is a constant here. Okay. So what we need to do is in that line. So in that line perpendicular to the OM line, in that you mark this distance. Let's assume this is 9.5 mm. So in this line, you need to mark that 9.5 mm. Okay. Let's take this as R, capital R. Okay. So the distance between OR is nothing but this A. Okay. You need to mark this. So the next step is you need to draw the normal. From R, you need to connect M. So if you connect M from R, so that will be your normal. And if you draw a perpendicular line That will be your tangent. Okay. So this will be your n dash, t dash. Next thing is the dimension. So in the question, the 60 mm is given. So you need to mention the diameter of this. So choose any line because we already have some inclined lines. I'm going to choose this line. I'm going to extend it, and I'm going to mention the dimension, that is pi 120. Okay. Next, by making a double line, we need to mention t dashes, tangent, and n dashes, normal. So usually I have used black color and red color marker, but in today's class I used blue and black. So the blue marker is for 2H lines and the black marker is for HP lines. Okay. Thank you.
Okay.
Yes, sir.
Yeah. Any point. Okay. Choose any point on the curve, and after that, just a moment. I will find an alternate for this. So just give me 2 minutes.
Fine. Yeah. Something like this. Okay.
Okay. So after doing this, you need to draw a perpendicular line to the OM line. Something like this.
So after that, what you need to do is you need to draw a perpendicular line to that particular line. So I'm going to draw a perpendicular line to that. So something like that it will come. Okay. So perpendicular to this line. So this angle should be 90 degrees. So next, what we need to do is we need to make a small calculation. We need to find A, which is nothing but a constant. It's nothing but the ratio between small r divided by theta. So the small r is nothing but that.
So the smaller is nothing but the distance between OM. You need to measure that with the scale, and the theta is nothing but the angle between P8O line to OM line. That is P8OM, the angle between that. So that is nothing but the theta, and the theta you need to convert that into radians. Okay.
The distance of OM.
What?
What is the need of A, the constant?
No, so you draw a perpendicular line, right? So in that you need to choose a point in that perpendicular line because that point is not known. So that perpendicular line can be of any length. So what is the length of the perpendicular line? To define that, we are calculating that constant.
Okay,
Sir, which
You are getting
angle
my
is
point.
theta, sir?
sir. Yes, sir.
What?
Sir, which angle is theta?
So the theta is nothing but the angle between P8OM.
Yes, sir.
Okay.
Excuse me, sir.
Yeah, tell me.
R should be in mm or centimeter.
R means which is R? R is in mm.
Okay, sir.
Okay. So if you are using R in mm, the answer A will come in mm. If you are using that in centimeter, the A will come in centimeter. That's it. Okay.
So OM line is there, right? So the distance of the OM line divided by.
So I am skipping this.
So if you do that, you will get.
So
what you need to do
I calculated that A value. I will fix that value in this perpendicular line.
is in that line. So in that line perpendicular to the OM line. In that you mark this distance. Let's assume this is 9.5 mm. So in this line, you need to mark that 9.5 mm. Okay. Let's take this as R, capital R. Okay.
So the distance between OR is nothing but this calculated constant A. Okay.
Distance between OR is nothing but this E. Okay. You need to mark this. So the next step is you need to draw the normal. From R, you need to connect M. So if you
So from R, if you connect to M, so that is your normal, and if you draw perpendicular to that, that will be your constant. Okay, is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Done. Okay, okay, thank you. So with this, I am
Sir,
closing
at
today.
what angle OR is on? Sir, at what angle